Thank you, Marcus. Thanks, everyone. Great to see so many of you are still here and I think awake, which probably means waiting for the bar to open. But hopefully there's 15 more minutes to explore a topic of direct food contact in packaging and maybe a transition towards paper packaging and some of the challenges behind that. So as Marcus said, my name's Simon. I'm the product and marketing manager for Sun Chemical. I'm not going to talk a lot about Sun Chemical. Most of you probably have heard of us. We're a company that makes pretty good inks for a wide range of substrates and applications. And probably within your daily life, you will have come into contact with a Sun Chemical product at some point, be that an ink, a coating, a colorant, or a polymeric solution. We're in many application areas. But I want to focus on the packaging market, and look, we're all aware that there's been a number of changes within the consumer, the FMCG landscape. Very few of us just do our weekly shopping in a supermarket now, and even if we do, those large FMCG brands are now competing for shelf space with smaller startup brands, especially online, but also in the stores. And they have to differentiate themselves from people with maybe more innovative products and a much clearer brand purpose in many cases. And often that brand purpose centers around the visual aspects, but particularly the sustainability. And the best way to demonstrate your brand purpose in front of a consumer, the first touch point of that consumer, is the packaging, right? It's our gateway to a product, to a brand, to a solution. And there's lots of multi-factors when you go to the store. So recently, I happened to be looking after my 10-year-old niece. We had to pop into a supermarket to get a few bits. And we were down one of the food aisles. And whilst I'm a print geek and picking up and looking at the print and what quality it was, as it done by inkjet, and as a type father looking at the price of it, what she was looking at was whether the package could be recycled. 10-year-old. And the Gen Zs of this world, the younger consumers, when they're looking at these things because they've grown up with it. It's in the education system. They've heard about ocean plastics. They know, they've watched the David Attenborough documentaries. They know about climate change. They know it's a problem. They know we need to do something about it. So their first thought isn't what the color is, what's inside the package, but genuinely it was, can this be recycled? So they tended to look more at the paper packaging. And some of the impacting trends that we see in that area are specifically centered around recycling and recyclability. So even within flexible packaging, we see a strong trend towards monomaterial packaging, right? Gone are, or going away are, laminated layers to provide protection from what's on the surface to what's inside the print. We're seeing higher barrier structures like coatings with aluminium oxide to provide a clear resistance, but probably the biggest trend that we see is a transition towards paper-based or fiber-based packaging. And that's great, but to do that, it still has to maintain the same kind of properties. No one's going to sacrifice what you get from a plastic packaging for a paper packaging unless it kind of does the same job, right? It still needs to have those same resistance properties. And then if I combine that with another concept of food contact, so more and more we're asked about food contact inks and technology and whether we have it. And when I considered what is food contact printing, two kind of simple thoughts come to mind. One is printing directly onto the food stuff, so you're contacting the food with the ink, and one is printing on the packaging, often the inside of the packaging, where your print comes into contact with the food stuff in the pack environment. Sometimes in a primary pack if you take something out of the pack and put it on top. So in terms of ink printed onto food, we probably think about this today as fairly niche area, quite a mom and pop style business where we're printing onto cookies, with messages, with brand promotions. things like that. You've probably seen printed birthday cakes. Some of you may have even had a pint of Guinness with your face printed on the surface. It's becoming more of a trend to the point where recently Oreos and M&Ms are doing a lot of personalization of their product, the product inside the pack, as a next stage of that packaging, bespoke packaging personalization. There's also other ways of using food, so direct food contact, and that could be printing scorch marks or branding onto burger buns, onto other baked goods, things like this. And you probably think, oh yeah, but this isn't industrial print for manufacturing, this is mom and pop stuff. But it's happening now, digital print on demand. So this is a print bar across a production line in their production process. So in this case, cookies come in, pre-bake, get printed, get baked, go to the packing line. So it's an example of inkjet being used in a manufacturing process. It's not disruptive offline for bigger, fast consumer brands. In terms of food contact packaging, we could think about a chocolate box, the inside of that, maybe the inside of a takeaway container, could be the classic fish box or fruit carton where the food quite likely gets in contact with the print. Could be, as I mentioned, promotional stuff or track and trace inside bags or paper packaging bags for flour or chocolate bars, which you often see, right through to maybe not food contact, but human mouth contact in terms of disposable cups, disposable recyclable cutlery, stuff like that. So there's lots of touch points, and all have challenges when we move to paper-based environment in terms of how we make them food contact proof. And when we're talking about food contact, it's from a chemistry point of view, and as an ink manufacturer, we have a number of key considerations. So the first one being the raw material selection. It's really important that all the raw materials that we source are fit for purpose, that they're screened for direct food contact. When they're going onto the food itself, it's another level of looking at non-intentionally added substances. Are they safe to consume? What levels of certain materials are permitted or not permitted? And every country has a different legislation on that, literally every country when it comes to food. It's also where we manufacture it. So in the term of if on edible, so if inks to be consumed, they have to be in GMP, food safe environments, FDA audited, all these things. So it's not so simple to set up a factory. But even on food packaging, you need to be in a GMP clean environment. And obviously, they have to be fit for purpose in the final application. But the route to paper-based packaging is a little bit complex because it's not really paper. Most paper packaging for food has a plastic layer on the inside of it to protect the food from the packaging on the outside, or to protect the outside quite often from what's inside the pouch. So you see lots of advertising. If you follow Guy on LinkedIn, you'll see many examples of paper becoming more increasingly used in packaging. And a recent good example is Absolute Vodka bringing out a paper-based bottle, right, which was a great marketing point for them, but just over 50% of that pack is paper and the rest is plastic liner, which they claim is recyclable. But when you look deeper into what that means as recyclable, you have to remove the plastic liner. You can recycle some of the fiber, but then the rest goes for energy capture, which essentially means it's burnt, but they can still call it recyclable. And within the standard recycling processing equipment, they can cope with up to 1.5% of plastic or metal within the fiber to get it truly recyclable. But the standards don't necessarily align with that. So in the UK, for a paper pack to be called recyclable, it can have up to 15% of plastic within the fiber composition. In Germany, it's 5%. In France, it can be up to 50% and still be labeled as recyclable. But what if we could take that plastic film out and replace it with a coating, a water-based food direct contact dispersion? So we get rid of, so we're direct food contact compliant. There's no plastic extrusion, there's no PVC, there's no chlorine. But of course, it still has to maintain the properties you expect from a pack. So it has to have the liquid resistance, the gas barrier properties, and also the ability to be formed into the packaging, so the hot or cold sealing compatibility. And within some, we have a range of coatings, both for primary food contact and direct food contact, that can address much of this depending on what the purpose of the packaging is and what the purpose of the coating is, be it protecting the packaging from the food item or the food item from the packaging. And I just want to talk about two examples of where coatings and inks can be used to reduce or remove plastic from an otherwise paper-based substrate. So if I went back to my experience with my niece in the shop, one thing that's kind of odd really is you get these sandwich packs, right, which is essentially a cardboard piece of packaging, but it's got this plastic window on. Not only has it got a plastic window, it's fully lined on the inside with a thin film of plastic to protect actually the outside packaging from any grease or things damaging the print on the outside of the pack. It's not really to protect the sandwich that's inside, because that's a pretty short shelf life. That's a fast turnaround product. But what if we could get rid of the plastic liner with a coating? And what if we could get rid of that plastic window and use a paper-based substrate and apply a dehaze varnish over it, so you get the function of the transparency, but you've eliminated the plastic from the packaging. We had another example which was shown by Sun Chemical at Interpack this year, which was a collaboration with Qualvis Packaging for a company called Whittaker's Chocolate. And Whittaker's are one of the biggest kind of chocolate providers in the UK for gifts and experiences. And here they did a project to remove the previous pack was 55% plastic, because it had a liner on the inside and the plastic tray to hold the chocolates. So instead of using a plastic, they could use a coating so that you remove completely the liner. You can also, because it's food contact, remove the plastic tray. And this was done with food contact conventional inks. But you see a fully plastic-free pack, highly recyclable, lightweight solution, and with massively reduced carbon emissions as well. So this is possible in conventional. One of the challenges we have in digital is that some of the materials that we need, or the specification of pigments and other materials that we need for them to be food contact, are harder to get into an inkjet formulation than they are into a conventional ink. But we've kind of already got a solution, right? Because we've got inks that we can print directly onto food, so they're already food safe. They can be consumed, we can eat them. So what if we could combine an edible ink with a direct food contact coating to start removing plastic from some of these packaging environments? Then you could start to think about the chocolate bar with the offer inside, you know, where you open it and you've got to find the code inside, and usually they've got a very poorly printed QR code or a barcode that you can scan, but you could do a full color image on a paper inside and then coat that, not with a plastic liner, but with a coating just to provide that liquid or gas barrier. But the ink itself, even if it comes into contact with the food, is edible, is printed on a daily basis onto chocolate bars in the first place. You could do the same with pouches, with track and trace. So there's examples of people wanting to put barcodes on the inside of flour bags, but the issue is the ink contaminating the flour inside if it's not direct food contact. We even have inquiries for things like printing on the inside of ice cream tubs. So there's perhaps a solution that already exists if you take one existing technology and another and combine them to really advance the case for a fully recyclable paper-based packaging rather than plastic. And it's not a solution for everything, right? There's no way paper will fully replace plastic in packaging. There's lots of benefits in certain examples for plastic. But it's a way of accelerating where it can be done relatively quickly, paper as a packaging process. Thank you very much.